Welcome back, students. Okay, for this next video, we're going to basically look at the equation of a tangent line to a function at a given point. So first, just a quick reminder as to what a tangent line actually is. Here's the graph right here of the function y equals x squared. And I'm interested in finding well, first off, the gradient of the function at the point 2, 4. So what I've done is I've drawn a tangent line that just touches the function y equals x squared at that point just there. So a tangent is just a line that touches a function at a single point. And the important thing about a tangent line, and one important thing about a tangent line, is the gradient of the tangent line is the same as the gradient of the function at that point just there, which is what this says down at the bottom. That's the critical thing about tangent lines and functions. So let's go ahead and actually do a question where we're trying to find the equation of a tangent line to a particular function at a given x value. So determine the equation of the tangent to the graph y equals x squared, take 4x, take 5, when x equals 2. And one thing you have to remember is we need to use, at some stage late in this question, we're going to have to basically use the fact that the equation of a linear function is y equals mx plus c. So we'll be using that shortly. So the first thing we're going to do is find the gradient. So to find the gradient, what I have to do first is find the derivative of that function. So the derivative of x squared is 2x. And the derivative of minus 4x is minus 4. Okay, we're given the value of x that we're interested in, so I substitute that in, and that tells us for this particular function, the gradient of the function at that point is 0, which you might recall means that the function is a horizontal line. Now the other thing I have to find out is the y-coordinate. We're not told the y-coordinate in this case, so the next stage, or the next step, is to substitute into this equation just here, substitute x equals 2, and evaluate to get y. So just put in 2 for x, and y comes out to be negative 9. So we now know that the coordinates of the point of interest is 2, negative 9. Okay, so now if you look at this equation here, I've got a value for y, I've got a value for m, and I've got a value for x. So I can use all of that to find a value for c. So we write y equals mx plus c. We substitute in the 3 values that we know. We do some simplifying, and we can get the value for c like so. And once you have a value for c, that means you now have the equation y equals mx plus c. Looks like that. But of course, 0 times x is just 0, and 0 minus 9 is just negative 9. And therefore, that's the equation of the straight line, the tangent line, just there. Okay, guess what I want you to do? You go ahead and do the same thing for this question just here. So stop the video, have a go, and restart the video once you've done as much as you can. Okie dokie, well, we're going to basically just go through the same steps with this equation. So step 1, find the derivative. Step 2, substitute in the x coordinate and work out the gradient, the value of the gradient, which means the value of the derivative, which means what the gradient is. So the gradient is negative 8. Once again, we're not given the y-coordinate, so step 2 is to write down the equation, sub in negative 3 in for x, and that gives us the coordinates of the point just there. Okay, now to find the equation of the tangent line, well, the basic equation is y equals mx plus c. We know what m is, we know what x is, and we know what y is. So we just substitute into the equation like so. and solve for c. Negative 8 by negative 3 is positive 24, and therefore c is 9. Take 24, which is negative 15, and that means the equation of the tangent line for this particular problem is y equals negative 8 subtract 15. So that's that application done. Once again, find some questions in your textbook that are similar to this and just practice on a few of them.